Hello everyone. Let's solve today's LeetCode POTD, count covered buildings. So the problem states that we are given a positive integer n which represents a n cross n city. Now we are also given a 2D grid buildings where buildings of x comma y will denote that a unique building is located at the coordinates x comma y. Now a building is covered if there is at least one building in all the four directions. Suppose this is a building, then this is covered if in all four directions there exists at least one building. Means there needs to at least one building on this side, at least one building on this side, at least one building on this side, and at least one building on this side as well. So if this is the case, then this building that we have at x comma y will be called as covered. So if we are given this 2D grid buildings which denotes the x comma y means of all buildings, then we need to return the number of covered buildings from all these buildings. And n can go up to 1e5 as well as the building's length can go up to 1e5. And we are also given that the coordinates of each buildings are unique. That means there are no overlapping buildings. Okay, so that we need to account them multiple times. So let's see our input. So we are given this as an input. So we can see like for this building, we have a building, means in the upper direction we have a building, in the downward direction we also have a building, as well as in the left as well as on the right. So hence this building is covered. But if we consider this building, we see like in downward direction we have a building, but in this direction and this direction we do not have a building. Hence this will not be a covered building. Similarly for this, we have in this direction, but in this and this direction we do not have any building. Hence this will also not be a covered building. So hence the output here for this will be 1. Now let's see this another case. So we have this building. So suppose we consider this. So on the right and on the down we have a building, but on the up as well as on the left we do not have any building. Hence this building is also not covered. Similarly, this is also not covered on up and right. This is also not covered on right and down, and this is also not covered on down and left. Hence the output here is simply 0. Let's see another input. So again we are given the similar input to input first. So we can see like this building has at least one building in all the four directions, and hence the output here is 1. Okay. So what do we observe like from the inputs that we have seen? What do we observe? Like what data can we like pre-compute to see like if we are at a particular building, then to identify in very fast time whether this building is covered or not. So if we are at a building x comma y, then if we consider the row x, means the column, means this will be x comma y. So if this is x, then if we consider this column y, then for this for this x we need to find the minimum y that lies in this range, y mini, and the maximum y that lies in it, right? Now if this building needs to be covered, then this y minimum should be less than y and this y maximum should be greater than y. That means there exists a building on the up which will be ensured by y max, and there exists a building on the down which will be ensured by y mini. And similarly, if we consider this row y, then we see that like if we find out the smallest minimum x and the largest x, then we know if this x mini is less than x and this x maxi is greater than x for this particular y, then that means that this building is covered on the left as well as on the right. Hence if for each x comma y we maintain two values, for this particular x we need y mini comma y maxi, okay, and for this y we need x mini and x maxi. Now at each step what we'll see, for this x we'll see whether this y mini and y max, so y should be greater than y mini and less than y max, and similarly for this x should be greater than x mini and less than x max. So if we are somehow able to store, means calculate this information for each xy, then in the end we'll simply check whether the y, means at a particular x, whether the y minimums and y maximums are allowing them to make it covered, and similarly for the y we'll see like whether the x minimum and x maxi are making the building covered on left and right direction. So now how we are going to like calculate these two values? Hence we need, for x we need a pair, and for y also we need a pair. So maybe we can create an unordered map. First for x, which will be storing a pair of int comma int, which will be denoted by this is the mini and this is the maxi. Now one map we need for the x direction and one map we need for the y direction. Now MP of x will be storing the y mini and y maxi, and MP of y will be storing the, means for each y, for each I it will be storing x mini and x maxi, the pair, and for each x it will be storing the y mini as well as the y maxi in the form of a pair. Okay, so if we are somehow able to calculate these two values, then in the end we will simply iterate through all buildings, and if we have the current building as x comma y, we'll see whether like the mini x mini y will be what, mpx of x dot first, right? Because we are storing mpx y mini and y maxi in mpx, and mpx of x will denote the pairs y mini and y maxi. So we'll find out the mini y and the maxi y, and it will be simply mpx of x dot second, and we'll see now. Similarly we'll find the maxi x from what, mpy of y. Okay, in that particular y, what is the minimum x and the maximum x? So it will be simply mpy of y dot first, and the maxi x will be mpy of y dot second. Now once we have all these values, what do we need to check? We need to check that y should be greater than or equals to mini y, greater than mini y and less than y maxi, and x should be greater than mini x and less than maxi x. Okay, so these values we will check, and if both of these conditions are satisfied, then we will increase our covered buildings count by 1, and in the end we will simply return this covered. And now how do we keep track of these minimums and maximums in our map? So we need to first calculate these values, then in the end we will iterate through buildings, right? So how do we calculate them? So we simply iterate through all the buildings. Suppose we are at x comma y, then that means we are at a particular point x comma y. Hence for this x that we have, we need to update the minimum, means maybe for this x we need to update the y, means we will update y mini with minimum of y mini comma y, and y maxi also will update with maximum of y maxi comma y, so that for this x these two values are updated. And similarly for this y we'll be updating the x mini and x max. So we'll update x mini as minimum of x mini comma x, and means okay, and we'll update x maxi with the same x maxi comma x. And now how will we like getting these values? So y mini was simply what, mpx of x dot first, right? And y maxi is mpx of x dot second. So using these two values will be means getting the y mini and y maxi, and then we'll be updating these two values at each step. And once we have updated, means for each x comma y we are aware like what are the, in all four directions, what are the minimum and the maximum coordinates that exist, then we'll simply be able to iterate through all the buildings and calculate this value. So I hope you are able to like follow the approach. As you can see, like we are using an unordered map, so this will be of the order of 1 complexity, and since we are simply like iterating through the buildings twice, so the overall complexity will be big of n only. So let's see the code as well and see like how we are implemented it. So we have simply created an unordered map of int, comma pair of int, comma int for both the mpx and mpy. Mpx means we will be finding y max and y min, and mpy will be finding x min and x max. Okay. Now we iterate through the given buildings. We have the x and y. So we want to see whether this x is already present in map or not. If this x is already present in map, then we need to update the y minis and y maxis. So int mini is equals to mpx of that. We will update the mini y as well as the maxi y, and then finally store it in our mpx of x. And if this is the first time we are encountering the x, that means for this particular x, this is the first time we have encountered any building in this case. Hence, y minimum as well as y maximum will be y only. Hence, we'll update mpx of x with y comma y. And we'll same we'll do for y as well. So we'll see whether this is the first y that we have encountered. Whether this is the first y that we have encountered. If it is the first y, we'll update it as x comma x. And if it has already been existed, then we need to update the x minis and the x maxis. So we'll update means find the new mini and new maxi and update it. Now once we have the entire map with us, we know like the mini and the maxi in each step. So what we'll do, we'll simply iterate through the entire array. For each x comma y, we'll find this is the mini y, this is the maxi y, this is the mini x, and this is the maxi x. Now we need to see whether the current y that we have, it should not be like, it should be greater than mini and less than maxi x. Okay, so since we means it should not be equals to mini y, it should not be equals to maxi y as well. So if all these conditions are satisfied, so either we can write this in this form, or we can simply see like this y should not be the mini or it should not be the maxi. And similarly this x should not be the mini x as well as it should not be the maxi x. And if this is the case, then we'll simply update our covered buildings count by 1, and in the end we'll simply return the count. So this is like the overall approach for this problem, and the overall complexity, as you can see, like we have created another map. So the space complexity is big of n, and as well as the time complexity is also big of n. So let's try to submit the code as well here and see like whether it got accepted or not. So we have written the same code here that we discussed previously, and let's try to submit it and see how. Okay, so currently the internet is not working, but we have seen that it means it gets accepted. Okay, so this will get accepted. And one more thing is like we have the unordered map of int comma pair of int comma int, means for each x we have created these two maps which are storing the y min and y max, and for each y we have created map. So instead of that, we can simply like, since x can go up to, x will go from, we know like the buildings of x comma y will go from 1 to n. So if, since this is already given, if it had been like 1e5 then it would not have been possible. So this, it is given that x is greater than equals to 1 and less than equals to n, and y is also the same. Hence instead of creating these maps, we can simply create a vector of pair of int comma int of what, for x we'll simply create suppose mpx, and which will be of size n plus 1. Okay, and now in each mpx of x we'll be creating these, storing these two pairs of y min and y max. So instead of creating these unordered maps, we can also use array here, because we are given separately that x comma y is lying between 1 to n. Okay, and similarly we can create mpy of n plus 1 as well, because the city size is n cross n. Okay, so I hope this is clear. Like we can use an ordered map or we can use a simple vector, but we can know that an ordered map will also have like big of 1 complexity, but obviously like this will perform better because of like no collisions, if because there will be no collisions in this case. So you can also use this approach instead of this. So I hope like you are able to follow the entire intuition of the problem and how we try to see for a particular building, how we analyze like what information we need to store, and once we identified that, then it was pretty simple. We just needed to iterate through each building and see like whether in all 4 directions there exists a building. So yeah, if you were able to follow, please do like and subscribe. And if you have any doubts remaining, feel free to comment down and I will be happy to help. Thank you so much for watching.